All right. Oh my. Why is the chat there? OBS is weird. OBS is a weird thing. Seems like when I test everything out, it works fine, but then it kind of dies on me, which is kind of odd. I don't know. Is anything else out of the way? All right. So today we are looking at. Let's see. We're looking at plugs, and endpoints if we have time. And then the timer, which is doing the same thing, which is really strange. I don't understand. OBS just seems to like not store everything the way it promises it will. Oops, what did I just do? Let's wait for everyone to get a chance to get in here, see if anyone else is around. I was testing my chat on screen, as you can see. So that's pretty cool. So let's lock this in. Let's restart the timer. Let's see if that works, which it might not. It did. All right. Today we're looking at plugs and endpoints, continuing to plug along in our Phoenix documentation. Feel free to ask questions if you're out there. Tell me what I'm doing wrong if you know. Stuff like that's super helpful. Tweet it out, so let's make sure that anybody who might care. Okay, cool. That's out there. All right. Another thing I did was yesterday we were having some Ecto database problems. I don't know what I did, but I 100% blew away all my functioning databases on my machine. No idea what happened. I think I did like a clean my Mac thing, and something weird happened. Something went awry. Um, I have no idea. Very strange. One thing I need to check with this is that the chat actually works. I'm sure it works. All right, so let's look at plugs. So plugs live at the heart. Okay, actually, you know what? I don't even have my code. Where's my code at? Stand by. All right, got our code. I had to make the screen a little smaller to fit the chat, so hopefully everything is still visible. So I actually went and installed Postgres yesterday just to get that right. Figure that's better than using MySQL, since I had to reset up all my database stuff on my machine anyways. Figure why not. So yesterday we looked a lot at the router. Whoops, that's not the router. Router. Um, I reset. I regenerated. That's why it's called Hello 2 Web. I regenerated everything after doing the database because I figured I'd just set it up fresh with the new database. So that's why everything might be missing, which I think is fine. Otherwise, it's a tutorial, so it doesn't matter. We're gonna build a real thing eventually. So plugs. I'm just gonna pull up my Twitchy. All right, plugs live at the heart of Phoenix's HTTP layer. Phoenix puts plugs front and center. Okay, cool. So we have plugs somewhere already. Yeah, these guys. Let me bump up the size. It's probably all I can fit. And make sure this is not. Whoa, what are we doing? Is all my. I literally upgraded, and uninstalled everything to get my database to work yesterday, so that was cool. Clear mix Phoenix server. Starting to be muscle memory there. Let's see. So plugs are kind of core to Phoenix, it seems like. They're using endpoints, routers, and controllers. Oh, the core Phoenix components like endpoints, routers, and controllers are just plugs. Interesting. Let's jump in to find out what makes plug so special. Plug is a specification for composable units. Okay, so we've looked at this before in a previous episode. They're composable modules. It's also an abstraction layer for connection adapters to different web servers, web applications, or web servers. The basic idea of a plug is to unify the concept of a connection that we operate on. This differs from other HTTP middleware layers such as rack, where the request and response are separated in the middleware stack. So I don't actually know a whole lot about rack, but the request and the response are separated in the middleware stack. Oh my gosh, all the notifications. Let me shut off my notifications. They're distracting. So I wonder, like, how does rack work? So rack is the Ruby middleware. Nope, that's rake. I want rack. Rack. I wonder if there's like an image we can look at. You're drunk, Google. Here we go. So rack is the interface between the application server and the web framework. So it just connects. Oh, here we go. Interesting. HTTP response, rack translates, and so on and so forth. It's not in Rails. Uses rack middleware, adapter middleware handler. The application server. So HTTP requests come into the application servers. They parse the request, and they send it to the middleware. Middleware then sends it to the application. That's probably enough for us to need to know at this moment. So this says that the basic idea of plug is to unify the concept of a connection. It differs from other middleware layers such as rack where the request and response are separated. At the simplest level, the plug's specification comes in two flavors, function and module. This is like net new things, right? So we need to pay attention. In order to act as a plug, a function simply needs to accept a connection struct. A struct is just that key value thing, right? No, it's a structure, yeah, key value thing. And options. It also needs to return a connection struct. So it needs to accept a connection and return a connection. So the connection gets passed through the function. So here's an example. Put headers. Given a connection, some key values. Reduce over the key values. Pass the connection and some function. To the plug. So this is where like Elixir knowledge comes in handy, which I need to figure out a little bit more of. Let me look at that actually. I think arrow Elixir. I think it's like a what's it called? A anonymous function. Yeah, so this is a lot like how a block works in Ruby, I guess. Enum map words fn word. So for each words, so this enumerates over each word, passes the word down into here, and then we'll run a function on it. Okay. So this is saying reduce the key values connection. I don't know why this passes connection twice. It's kind of odd. Plug connection. So plug connection. Put the response header connection to string k. So if we look at like what plug connection does, put response header, put resp header, gives a connection, a key, and a value. So we have a connection, a key, and a value. Yep, that makes sense. Adds a new response header key if not present. So that's mute. That's essentially taking in a connection and putting a new one on. Adds a new one and then returns it obviously. So this is reducing over each key value. And I guess reduce would be worth looking at for a second. Elixir reduce, just to understand exactly reduce enumerable. So we're looking at the 4 arity, right? 1, 2, 3, 4. Because the second and the fourth are both connection. So the second, I'm not sure why there's an extra argument there. Because there's a, whoops, there's an enumerable, which makes sense. That's the key value. So that's what we're iterating over. We pass the connection in as the second item, which is the accumulator. The initial value of the accumulator is ACC. The function is invoked for each element in the enumerator with the accumulator. The result is returned by the function and used as the accumulator for the next. The function returns the last accumulator. So I guess the question is, and this is maybe not an answerable question. We'll move on. I just don't understand why there's a fourth connection. Oh, maybe this is the actual reduce being passed down. It's just not using like that thing we just looked at. Function word. Interesting. Huh, I don't know. Not sure. I think this is the con reference here. So this is actually the function call, that the parameters to the reduce function, and then it's saying given con, pass it into here for each one. Pretty simple, right? Yeah, sure. It is pretty simple. This is just me because I haven't done a lot of Elixir, so I need to wrap my head around exactly how it's doing that. Pretty simple, right? This is how we use them to compose a series of transformations on our connection. So we plug, put headers, pass in a struct. So it's set up here, it always accepts the connection, right? Excuse me. It always accepts the connection. Is that what it said? Accept the connection. Where did it say? There it is. It also needs to return a connection. So it accepts a connection, returns a connection. So this assumes a plug is getting a connection and returning a connection. Put headers given this struct. So this is our key value of all the different headers we want to include. It gets the connection in. It iterates over these because of this, and it updates the connection, returns it. So the reason it's called a plug is because it's plugging into the connection and doing something with it. Put layout is another one. By adding the plug contract, put headers to, put layout to, and even action to. Action meaning, I don't know where they got action from. I know that I've seen that before. I don't remember. Turn an application request into a series of explicit transformations. It doesn't stop there. To really see how effective Plug's design is, let's imagine a scenario where we need to check a series of conditions and then either redirect or halt if a condition fails. Without a plug, we would end up with something like this. Oh my. So we have a controller, right? We have a show function, accepts a connection in the params. It has to, so it's doing a case here. So it actually has to authenticate the connection. If it's okay, find the message. If it's nil, say that wasn't found. If there is a message, authorize the message. If that comes back as an error, so you can't access that page. Yeah, this is a disaster. Notice how just a few steps of authentication and authorization require complicated nesting and duplication. Yeah, that's terrible. Luckily we have plugs though. Plugs are sweet. So we're plugging authenticate into the connection, plugging fetch message into the connection, plugging authorize message into the connection. So now we know when we show, we just have to render because we know it's been authenticated, fetched, and authorized. Render the connection, show page. It's amazing. I like it. And then our plugs are even, oh, they're defined right here. So find the user if it's okay. So this is doing, these case statements are kind of neat. So it's saying for the cases where the different things that can happen here, you just do an anonymous function and return whatever happens. So this is actually interesting. This is connection being piped into put flash being piped into redirect here and then halting. I'm gonna halt Elixir halt just to make sure I understand. Halt, halt, halt the connection. Halts the plug pipeline by preventing further plugs downstream from being invoked. So that's how you escape. That's fantastic. So this is doing like a hard exit, basically. It doesn't even let you get to fetch message because it gets halted. Very cool. Very, very cool. By replacing the nested blocks of code, we flatten the series of plug transformations. We are able to achieve the same functionality in a much more composable, clear, and reusable way. Now let's look at another flavor of plugs, module plugs. All right, so that was function plugs. That makes perfect sense to me. And that is the best way to write the code. We've done this in Ruby at my work where we have pipe Ruby. And essentially you pass any arbitrary thing in, and then you run it through a bunch of pipes, and at the end it returns that thing you passed in. It's exactly what this is doing, and it's super, super nice. Module plugs. Module plugs are another type of plug that let us define a connection transformation in a module. A connection transformation. Module only needs to implement two functions. Init, which initializes any arguments or options to be passed in. Call, which carries out the connection transformation. Module plugs are another type of plug that let us define a connection transformation in a module. So is this just saying it's functions, but instead of throwing it in the controller like they did here, you actually put it in a module? I think that makes sense. To see an action, let's write a module plug that puts the locale key and value into the connection assigned for downstream use in other plugs. So we're defining okay, so we're just adding a locale key to the connection, which makes sense, so that you could like change languages when rendering a page or something like that. So here's our locales, which I don't understand. Elixir at symbol. Is that like, what is that? What is that? Module attributes. Module attributes in Elixir serve three purposes. They serve to annotate the module, often with information to be used by the user or the VM. They work as constants. They work as temporary module storage. So this is just a constant. This is just a constant. And we're importing the connection module off the plug module. Plug. Not sure. Let's see. So it defines init and call, right? That's what it says here, call to. So this is doing pattern matching again. So this is call to. So this accepts one argument here and one argument here. Remember, that's our sign for we don't care about you. We're not going to use you. This is accepting the same number of arguments, but it's basically just saying pass in the default or any argument. So basically this matches first, right? Because it matches top down. And this says if the connection looks like this, so if the plug connection struct that this is called on has a params key in the value of a map, right? Is that what that is? Elixir map. Gotta remember. Gotta commit to memory. Yep. Elixir map. If it has a locale with some value, we're gonna set that value to loc. When the loc, okay, this is interesting. When the loc is in locales, so if we pass in foo's not in here, so this doesn't happen because it's not in here. But if it is in there, we should look up assign Elixir plug. What does assign do? Assigns a value to the key, to a key in the connection. Okay, so that's pretty darn simple. It just assigns the locale key to the value of whatever is passed in. That essentially, it's not mutating, right? Because it's functional, but it's probably making a new copy and returning it. I'm guessing they're immutable. I don't know. I mean, I don't know anything, but that's my assumption, is that it's returning a copy with the new key. And then that ends because that matches. It wouldn't go down to here, I don't think. Right? we're able to add this module plug to our browser pipeline. So that would go somewhere like this. So it would be like, say we accept that, we fetch all this stuff. We could even do like plug. I guess it would be plug. Oh, it's right here. Interesting. Plug hello web. This isn't going to work, obviously, but hello web.plugs.locale. And so that's adding English. That's adding the English locale to the connection. So that in here, if you wanted to grab that, you could do something with it. Get rid of that because it's not going to work. So we're able to add plug hello web plugs locale n to the init1 callback. Init, so this is the init1 right here. So init default, do default. Makes sense. We pass the default locale to use if none is present in the params. We also use pattern matching to find multiple call functions to validate the locale in the params and fall back to n if there's no match. Oh, I see. So we're passing in default here. So it accepts a parameter n, sets to default, do default. I do kind of wonder like what Elixir def do. Like what is the do? Does do just like, is that just an arbitrary thing? Do. Oh. That's how all, what am I talking about? That's how all functions are set up in Elixir. So that's just saying return, essentially return default, n, return default. So this is passing in n, and it gets passed into a init. And then when it gets called, it says, when it's in locales, do blah. And if it didn't match, if it wasn't passed in, it just says default n, do assign the locale to n, which is what we set in the default in the init. Makes sense. That's all there is to plug. Phoenix embraces the plug design of composable transformations all the way up and down the stack. This is just a first taste. We ask ourselves, could I put this in a plug? And the answer is usually yes. So the question is, anytime you're doing anything in the pipeline that should happen on any call, you could create either a module plug or a function plug. Drop the function plug in your controller, create a module plug, and include it. Now, I guess it's called directly, so you don't have to include it or anything like that. So that makes, I think that makes sense. That's it. That's everything. It's amazing. That's so simple. That's exactly the way it should work. Let's just make sure anyone didn't talk to me. Nope. Okay. Not that I expect anyone to care, truthfully. On to endpoint. We good with plugs? I think so. Yes, we're churning right down the whole list here. All right, let's check. Do a quick time check. 17 minutes. We're in great shape. Endpoint. Phoenix applications start the Hello Web endpoint as a supervised process. The obvious question is, what is a supervised process? What's process supervision? A form of operating system service agreement in which some master process remains the parent of a service process. Benefits compared to traditional process launches. I know nothing about how any of this process stuff works, truthfully. So, so endpoint is basically run, and the system watches it. By default, the endpoint is added to this tree, to the supervision tree in lib hello application.ex. Application.ex. Right here. Start. Here's all the child processes that are supervised. We're watching the ecto repo, and we're watching the endpoint. Each request begins and ends its life cycle inside your application in an endpoint. Each request begins and ends its life cycle. Okay. The endpoint handles starting the web server and transforming requests through several defined plugs before calling the router, right? Strategy, one for one name, hello to supervisor, supervisor start. So that's not in the application though. Is it? The endpoint handles starting the web server and transforming requests through several. Okay, is there an endpoint? Endpoint.ex right here. Here it is. Hello web endpoint. Okay. Endpoints gather together common functionality and serve as an entrance and exit for all HTTP requests. The endpoint holds plugs that are common to all requests coming into your application. Let's take a look at the endpoint. The first call inside our endpoint module is to use the Phoenix endpoint. There. That's a macro. With the OTP app. The OTP app is used for configuration. This defines several functions on the Hello endpoint module, including the start link function, which is called in the supervision tree. What does that even mean? The first call inside of the endpoint module is to use Phoenix macro with OTP app. The OTP app is used for configuration. So I guess the question is hello to .app, right? Because that's saying hello to .app. What is that? Whoa! This is like a this is crazy. What is this? That almost seems like compiled. What if this defines several functions of the endpoint module, including the start link. Start link? Yeah, I don't know where that comes from. Interesting. Let's come back to this. This isn't clear to me at all. Next, the endpoint declares a socket. Right? We talked about sockets last time. Here we're just declaring that such a connection will exist. So this just defines that sockets exist. Next comes a series of plugs that are relevant to all requests in our application. We can customize some of the features, for example, enabling gzip true when deploying to production to gzip to static files. Static files are served from priv static. We should take a peek at the files real fast. Priv static. So here's all of our, we need that before any part of our request makes it to the router. Right here, plug static. Gosh, this is so small. Let me make this. So serve at slash the static files from priv static directory. You should get gzip true if you're running Phoenix digest when deploying your static files to production. Plug static, so it's plugging in a static plug to the connection. It's plugging in at slash from hello to, only passing in certain files. Cool. If code reloading is enabled, a socket will be used, oh interesting, to communicate to the browser that the page needs to be reloaded when the code is changed in the server. This feature is enabled by default in the development environment. So if code reloading, I wonder where that comes from. Where is... This is configured using config hello. Is there a config like section here? Config hello to right here. Import mixm.exs. So that's probably development.exs. Ex dev.exs right there. Code reloader true. Okay, that's neat. Let's see. So the socket, yeah, so back to the socket. So socket, it defines a socket. Defines a socket. Phoenix live reload socket. And it points it to this socket module. Plugs in the live reloader and the code reloader. Interesting. See, plug request ID generates a unique ID for each request, and plug logger logs the request status code. That makes sense. Plug session handles the session stuff, store them in cookies, give a key, salt it. By default, the last plug in the endpoint is the router. This is what I was wondering, but that makes total sense. The router matches a path to a particular control action or plug, right? So if you think about it, it needs to define the socket outside of the router, because obviously we don't route socket stuff inside of the router. The endpoint can be customized by adding additional plugs to allow HTTP basic auth, cores, subdomain routing, and more. Faults in the different parts of the supervision tree, such as ecto repo, will not immediately impact the main application. The supervisor is therefore able to restart those processes separately after unexpected faults. It is also possible for an application to have multiple endpoints, which with its own supervision tree. That's really cool. So if like say like where's our ecto? That's not in. I guess that's in the other application here. This. So like if this dies, it doesn't affect this because the main process can restart those, which is pretty rad. There are many functions defined in the endpoint module for path helpers, channel subscription, broadcast, instrumentation, endpoint configuration. All these are covered in the endpoint API docs. We'll check that out in a second. How much time do we have left here? 9 minutes. Let's try to get through these and then we'll look at that. To prepare your application to serve requests over SSL, we'll need to add a little bit of configuration and 2 environment variables. In order for SSL to actually work, we'll need a key file and assert from assert authority. So I want to read this just so I can get a sense of how you'd implement something in here. So we configure the endpoint. Configure. Where's that configure thingy happening? Here's an example of prod.exs. Prod.exs. So here's your configure your endpoint, HTTP URL cache, etc. Without the OTP app key, right here, right? We can ignore all this, I think. So the interesting part is we're configuring our endpoint config, mix config. Module for defining, reading, and merging app configurations. Most commonly, this module is used to define your own configuration. All the macros, including import config, are used to help define such configuration files. Wonder when this is called. Config. It's not in here. I wonder like how this all. I guess it all fits together probably in Phoenix endpoint. I'm guessing. Whoops. Phoenix endpoint. Lots of documentation. Lots of documentation. So for example, if we were to look at endpoint or in prod.exs, let's look at cache stack manifest. That seems like a thing that would be easy enough to find. Runtime configuration. So that's saying something that you can set. The path of the JSON manifest file that contains static files in their digested version. This is typically set to priv static cache. So in our prod.exs, we set it just to that. And I'm guessing when we set, because we're setting config, so we're config the config method, the config function, config must be on here, config, access the endpoint configuration given the key. Key, hello, whoops. To default. Okay, that's how that all works together. So config on this. We're just gonna skip this because I don't think it's actually relevant right this second. This is all like how to configure stuff in the in the endpoint itself. So really, to summarize the endpoint, going back to the top, it's a supervised process, right? It's added to the tree. Each request begins and ends in the endpoint, and it handles transforming the request through all the plugs before calling the router. So we can set up a whole bunch of default stuff in here. The request comes in, the endpoint handles it, and then passes it off to the router. So it's kind of small, but this is where you're gonna run. Like if you ever need to do stuff like log or whatever, you do it in here because it wouldn't make sense to do it in the router. For example, if fetch flash were relevant to every single possible request, you would do it in the endpoint, but it's not. It's a flash. It's only relevant to the browser. So that's why it's in the browser scope. In the browser pipeline, not scope. That's the wrong word. The browser pipeline, which could be scoped to certain URLs. So this is really just plumbing to understand how things operate end to end. 4.5 minutes left. Let's dig into the endpoint methods, just kind of curiosity. The endpoint is a boundary where all requests in your application start. It is also the interface to your application for its underlying web servers. Provide a wrapper for starting and stopping the endpoint as a part of the supervision tree. There's 3 responsibilities. I like that they just tell you this stuff. It's so simple. Define an initial plug pipeline for a request to pass through. That's where we're seeing kind of these plugs, boom, these plugs, boom, boom, parsers, method override, head, session, in the router. That's your basic plugs that have to run. You get in the router and you can have all these other plugs that happen in a pipeline for sure. And then host a web specific configs. So your config lives within the context of the endpoint. And that's happening here. So the configs change. They utilize some of these default settings, which is kind of crazy. Okay. Configuration. All these things. Endpoint API. Instrumentation. This is all stuff we might have to use at some point. There's all sorts of juice in here. All right, I think that's it. We can end early today. Got plenty of real work to do today, but this gets us further down our thing. So next time we will get into controllers. That's a doozy. That's another doozy. So that'll be a whole episode there. All right, thanks for playing. Appreciate your presence or lack of presence. Some people came in and out, but we do this for myself. You know what I mean? We do this for me who watches this in an hour. All right, till tomorrow.